So let's draw these coordinates that they've given us in the problem. A is at 7, I'm just doing a rough sketch, 7 comma negative 3, that's A, and then B is at 5 comma 2. It moves from point A, so it starts here going towards point B. And it does that within 15 hours at a constant rate. Coordinates are given in yards with respect to the standard x and y coordinate plane. Find the parametric equations with respect to time. So we're looking for parametric equations with respect to time. That means we want to separate x and y into two separate functions. Instead of depending on each other, we want them to depend on a variable in common on time. So to make that happen, let's look at the change in x. To go from 7 to 5, we backed up 2 units, right? And it took us 15 hours to go from A to B. So we're going to divide the distance traveled by the number of hours. It's like kind of like calculating miles per hour. This is instead yards per hour. So that is going to be our relationship for x. It travels at negative 2 over 15 for every 1 hour, for every time t increases by 1. You know, if you plug 15 into this equation for x, 15 times negative 2 over 15, that makes negative 2. That means we back up 2 units on the x-axis, which is exactly what happened up here, right? We backed up 2 units on the x-axis. And then let's try to come up with an equation for... Actually, so our starting place was 7. We have to add 7 here, okay? Because with a function, you should be able to plug in the information and get out the values we see in the real world. So if you were to plug in 15 in here before you put that plus 7, 15 times negative 2 over 15, that makes negative 2. But that's not the coordinates after 15 hours. Negative 2 plus that starting 7 gives us 5. Okay, so it'll make probably more sense when we check out the next one. Same process for y. The change in y, we started at negative 3. We ended up at positive 2, so we increased 5 units. But that was over 15 hours. So you could say 1 over 3. That would be a little easier. So this is the rate of change of the y units for every 1 t hour increase. And we started at negative 3. So I'm going to say plus negative 3, or you could say minus 3. And let's plug in our information. If we plug in 15 hours, that means we should end up at 2 hours on the y-axis. So if you plug in 15, 5 over 15 times 15 makes 5. 5 plus negative 3 makes positive 2. Checks out. Gives us what we were supposed to get from B. So these are our parametric equations. This one looks good. And then 5 over 15, that's 1 over 3. So this is the correct option. The matches the functions that we just made.